Hey, what's up everyone? Welcome to the stream. So, last week, I was working on the scope stuff, basically for variables. I can give you a little demo of what we've got so far. Let me see here. Here we go. So yeah, basically just a simple thing. I was messing around with adding a scope here. So if I hit F5, I need to attach here. All right, so here we go. Boom, we're in main. Hit F10. I mean, already we can see it says locals here, and it's got nothing. And we have another locals that says C, which is a bit weird, right? So it already knows about this guy. It's not claiming anything. As soon as I'm going to hit F10 here, now all of a sudden it's going to show A and B and C. All of them have garbage values. A gets a 0, C inside gets a 1, and a 2, A gets a 3. Now we're out of that scope and we're still showing C. So yeah, basically that's what I've got right now. So yeah, so the reason why it looks weird like this is because of a misunderstanding on my part on how scopes, or what scopes really mean. I had the impression that logically scopes had something to do with the scopes that you see in your code, right? If you tell it, I'm in a function that has, you know, one scope and then a second scope here, and that these variables belong to it, I was supposing that the debugger would then ask, okay, well, which scope am I in? Let me display the variables from this scope and its outer ones. But that is not how it works. It turns out that a scope, from what I understand anyway, is sort of like just a name for a bucket of variables. Just give me a second. Okay, so yeah, so basically, like, the name scope here has, it is going to be shown in the variables view here. And it's just like a bucket of variables. So like, the thing about them, and it's weird, right? Because I don't know if like that's what it was. I think I'm not completely off in thinking that it had something to do with scopes, not just because it's called a scope, but also because when you look at scope, it has a whole bunch of information, optional information, but you would think that this optional information would be somewhat useful, like the start column of the range covered by this scope, you know? So it's got this concept of range, end column. It's got the, like, it has line here, the optional start line of the range covered by the scope, and the end line. I tried to set those. I hard coded them here just to see if it would have any effect. It does not. If true, the number of variables in this scope is larger or expensive to retrieve. Okay, whatever. But, you know, it has something to do with it seems to have something to do with like what we think of scope, right? Like a scope is a certain section or sequence with a start and end line of variables. And so when I try to set it this way, it doesn't seem to be interpreted that way anyway from VS Code. So here you see name of the scope. So they say such as arguments, locals, or registers. This string is shown in the UI as is and can be translated. So right there, it's telling you, that's a hint that I was wrong, I suppose, because one scope for arguments, one scope for locals, and one for registers implies that there would only be one scope for all the local variables and not multiple scopes. So yeah, you know, a bit strange. Number of named variables in the scope. The client can use this optional information to present the variable in a paged UI and fetch them in chunks. Not quite sure. So maybe if you have like thousands of variables, you can set this here and then, yeah, I'm not sure yet what that means. Yeah, and so there's also this thing here about how it's going to be presented in the UI. Now I set it, but you can see again those three types, right? Like those here, arguments, locals, registers. The hint is arguments, local, and registers for the presentation hint. So I'm gonna mess around with that because I'd like to know what that means. There's also optional source for the scope, so you can actually point it at source. We could do that if that's useful. And then you got the variables of the scope. Well, anyway, a way to retrieve the variables. So see, that too implies that a set of variables are bound to this scope, right? But like I said, you know, I tried to do that. I actually have a proper way of getting scopes, and doesn't seem to make much of a difference. In fact, it just looks weird. So I'm traversing my scopes in here, and I'm creating a DAP scope for each, and as you saw, that didn't seem to help very much. Like if I was to, like, you know, I could say locals 1, locals 2. It's like a scope 1, scope 2, you know. So I don't think, I guess based on what we see here, I don't think that's going to help us very much. So I'm curious about this presentation hint. I saw there was registers. Curious what that looks like. Right? Registers, and we'll try arguments too, just to see. In fact, what we can do, no, okay, yeah, let's just try registers here. Stop this if I haven't already. Let's build. And let me take out the wait for debugger that I have somewhere here. It's going to go a little bit faster for me to try this out. So that pretty much looks the same. I'm not seeing any difference really. So maybe the presentation hint here is more useful in something like Visual Studio. So Visual Studio has different panes, right, for where to display like your watches, it has like an auto to show you your, I guess auto would be what locals is used for, maybe. Yeah. And it has a registers window. So my guess is that that stuff is really mainly useful for Visual Studio and other types of IDEs, whereas VS Code doesn't really do that. It's sort of like, it puts everything in here. So if I add a registers view, and I'm thinking of doing it, it'll just basically be locals, registers, and I guess if you have parameters to your function, you could show them as a separate, you know, bag as parameters. I suppose that's what we would do there. I'm not sure. All right, so given that it is working that way, we're going to change up how we implement this. So what am I going to do? So I'm going to get rid of this. I think I even wrote here, yeah. So DAP scope isn't the same as a C++ scope. It's just a bag of variables that's displayed in the debugger. I need to scopes request. So same as now, except maybe no need to set variable reference ID or set it to a constant that means locals. Later, we might add a DAP scope for registers. And in the variables request, if it's locals, get all the scopes for the current function that encompasses the current PC and populate with all local variables of these scopes with their values. So I think that's what we're going to do. So let's do this like this. We're going to go and later on we'll do like, you know, what was the other one's parameters? So I guess we could go like this, right? I mean, I could just always set it. I don't know. Do I always want to show variables if there are none? Like if you go into a function that has no variables. Yeah, maybe we do. Because I can also say like if, and what about if I step into a function that has none? Yeah, I think we're just going to always set it. I think. I don't know. It's like almost, there's almost no point. I could just like do like responses. Oh yeah, okay, I see. Let's say, okay, let's go like this. If I have a function, shared pointer, sure. So if I have a function, then DAP scope, basically just copying the code from below. Locals, we'll do presentation hint, whoops, like that, and we'll set its variable reference ID to like that. Remove this. And all right. I can't use the PC because that's right. If we're clicking on different call stack frames, I want to show the variables from the scope where I am at in that call stack frame. Right. So the thing is that I actually lose this information by the time I get into the variables request, which is kind of silly. So maybe what I can do is, let me see. I'm really not sure what you're supposed to do. It's going to make a request for the stack frame we've selected, which is why I store the frame ID here. But this frame ID doesn't make its way. Like the only thing I can set is really the variable's reference here. Now, if I set that again to the frame ID, I suppose I could get it back. But then what I need to know is if I'm at the top of the call stack, I do need to look at my current instruction. But if I'm not at the top of the call stack, I'd like to know where am I at, where am I calling from in order to get the scopes from there. So this is somewhat similar to displaying the call stack itself. But in this case, I need to grab the variables for all the values. It's really not obvious. And also this here. Yeah, that's true. So this is also not going to work for when I click on anything other than the top of the call stack, because I'm using the current stack pointer, but obviously I need to have saved the stack pointer. Let me see here. Oh, so here it is. I do have this. Value that was stored in the CPU stack pointer just before the function was called. Okay, so I can use that. So I need to be able to get back to my stack frame. Which is what I'm doing up here. So when we do a stack trace request, for each of the stack frames, I am storing the frame address. Maybe I need to do less, maybe I need to store not the frame address, but maybe a way to get back at the stack frame itself. So maybe I could store like an index into the call stack rather. So then I can actually grab my call stack and do some stuff there. So if okay, so let's say I store the index to my call stack into the frame ID here. Then when we click on a call stack entry, and it asks for scopes, I can create a variable scope and then I suppose store again the same value here, so that when I come here and it's saying, okay, let's grab the variables now for that, I can say, all right, let's look at the call stack. If it's the top, we'll use the program counter to know where I'm at. Otherwise, we'll use what I'm calling callee address here, which really is the caller address, to grab the scopes. The only thing is, yes, I just tried to call this frames function. Oh, okay, no, that's it. All right, we'll do this one step at a time. But I think my idea of trying to store the call stack index might be a good one, maybe. So let's come here. And so actually we're going backwards to the frames here. Okay, so I think I can do, what is it again? It's stood, what's that function again in the standard library that gives me the offset of an iterator from the beginning? It's distance, I think. First, last. Yeah, that's it. I don't know if it'll work because I'm using a reverse iterator here. So asking it to be the first one might not work here. That's annoying. Alternatively, I guess I could do frames.size minus I. Do this instead. Store this as a DAP integer. I think this is okay. So now if we do this, store call stack index. So over here, it's not this anymore. It is our call stack index. Okay, now grab the call stack, frames of this index. So now we've got our frame back. Yeah. Okay, so this gives me the frame address, and then if it has a function there, then I create one of these. So here, I'm going to try putting back the call stack index in here. So then when it asks for the variables, what we want to do here is go like request dot variables reference. So same kind of deal, I think. Okay, so now we've got our call stack frame. So if, all right, actually let's go like this. UN16T cur address. Now, if our call stack index is like the top of the call stack, I don't even remember. I guess it's 0. Yeah. So if we're at the top, actually no. We push. So it's more like if we are equal to let's do this. Bool at top. And we'll say, so if we're at the top, we're going to want to use the current program counter. What's the problem here? Oh, right, frames. What size? Otherwise, is it frames like this? It's a function, right? Okay, so otherwise, what we want to do? We want to use the frames, what I call the callee address, which I need to rename. The address we're calling from, but not, yeah, it's so confusing. No, that's it. Right, not quite right. Let me do this a little bit better. So I'm going to auto ref frames because I'm going to need to access them. I can const that. So I've got the frames. Current frame is this. But what we want to know, if we're at the top, we do this. If we're not at the top, what we want to do is we want to go frames of call stack index plus 1 call the address. It's confusing, but basically, if we're not at the top, we want to, or let's say the one below the top, we want to use the top's caller address, where we were called from. I really do need to rename this to caller address, but anyway. It's because it depends on where you, from which point perspective you're seeing. But from the perspective of the frame itself, it is the caller address, right? Or maybe not. Address of instruction that called this frame's function. So maybe it's -1. Yeah. Very confusing. Let me see something. Let me think for a sec. So we push a frame on the call stack. And we say you were called from this address. Yes. I think I did this in my debugger. In the backtrace code. Print call stack. Yeah, it's -1. Although in this case, 0 represented the top. So maybe that's less confusing. Instead of what I tried to do here. Instead of saying what's the index, I should go like I is the, just like I did here, I would be like the top, and then after that we push from there. So let me try that instead. I think that's going to make it less. Store reverse call stack index. In reverse. So 0 is top of stack. Although I don't actually have iterators, so that's going to be a bit weird. Ah, jeez. Okay. Yeah, that's why I'd put plus. Where am I again? Here. Yeah, it is +1. Okay. So that's the current address. All right, cool. So now comes the part where we grab our current function I guess I don't really need that here. But what we want is what I was doing up here, which was to grab the function, here we go, from the current frame's address. So we grab our function, and now we need to proceed to collect the scopes from outside in for only for the scopes that actually encompass the current address. Or I guess say collect variables from all scopes that encompass the current address. So the thing is, the way I had done this was I had a traverse function to traverse all my scopes, and this would do an in-order traversal. So it does go from the outermost and then go inwards. That's good. But I don't think I can check. I don't have the information yet in my scopes for the range that the scope encompasses. So let's say I grab this. So one thing is we're going to create the scope. Oh, that's already been created, so we don't need to do this. What we need to do is this here. In fact, all of this here. Sort of. See, right now my scope doesn't have that information, right? It's just got children, parent, and variables. I need a range here. So it's kind of like to do if scope dot whatever range contains, and then we'll put like her address. But for now, we're just going to try and collect all the variables from all the scopes just to see if this works. So let's see if this what this looks like. Let's see. What do we got here? Yeah, okay. So this doesn't like. We're gonna have to cast this, I guess. It's a size T. Yes, I know it's a possible loss of data. It's all right with me. Hence the static cast. Is it the subtraction it doesn't like? No, I is a size T. Okay, the following warning is treated as an error argument. Conversion from size T to int. Maybe I'll be explicit because I think I can assign an int to this. Yeah. frames. Okay, what's the problem here? Non-standard syntax using ref to create a pointer to member. What's the deal here? Oh, right. That. It's a function call. Another size t. Okay. I should probably attach a debugger to this, but let's just see if it works. All right, so right now I got no variables, and I still have no variables. So that did not work at all. Okay, so let's put some breakpoints in here and see what's going on. So I'll put one here. So when we're collecting our call stack, we should come in here, and then over here, I'll put one there and one here. Oh, wait. Did I not build? Did I not build? Maybe not. Okay. Attach my debugger. Okay, so we've got index 2. That makes sense, I think. 0, 1. Oh, actually, no. I is 0. Oh, I guess I need to subtract an extra 1 from there. Reverse index logic. Always the best. Maybe I should just change this and... doesn't matter. I was thinking maybe I should just move forward, but actually we do want to show the call stack in reverse, so this is the way to do it. Okay. F5. Attach. All right, what did we store? We stored 1, that makes sense. And then after that, we're going to store 0. So that's 1, that's 0, F5, 1, 0, gets to ask for it twice. Okay, so here we are, call stack index. We've got 1. So no variables yet, F10. Hitting our breakpoint again. Here it's going to say give me at index 1, which is the top of our call stack, so that actually makes sense. Show the function name if available. So that's okay, so that's cool. Sure calls that a lot. Call stack index is 1. So here we are doing the scopes request for the top of the call stack. So the frame address is here. So we're going to say we're going to present locals here using the same call stack index as the variable reference. F5. So why didn't I get the call for variables here? Oh, yeah, right. Makes sense. We need to actually add this to our response. That would help. So basically, I was not adding this DAP scope to anything. So it was not making a request for the variables. since I didn't tell it about any of the scopes. Okay, so we should get a bit further now. 5 in here. I'm gonna remove the breakpoints up there because they trigger a bit too often, and we know it's working now. Okay, so here we are creating scope for call stack, top the call stack, which is correct. Hit F10. So here we are again. We're at the same top of the call stack. And now we got our variables. So we grab our call stack, we get our index here. It's 1. Are we at the top? This should be true. It is true. So we grab our program counter, which cur pc : x. Cur address. (9a), that seems right. Get our function. So now we do this traversal thing. I think, put my breakpoint in there. So we're going to be basically going through, I think there's only 2 scopes, right? Let me see, function. I've lost my, I got to be up here. How many scopes we got? So we got 1 scope, and it's got a child, which itself has no children. Right, that makes sense. So let's just go and see what happens. Okay, there we go. ABC. So that corresponds to this. Now, technically, we shouldn't see C. We shouldn't see C, because we're not, like, that's not part of the range of the current scope. Like, this scope, outer scope, has A and B, but not this one. So what I should see here is only A and B. So let me remove my breakpoints here. Okay. Okay, so that's good. So when I click on this one here, there are no scopes, no variables. Yeah, maybe you shouldn't say locals if it's empty. It does look kind of funny. All right, so let's focus now on getting those ranges in there for the scopes. We are getting much closer. I guess I could trash this and this as well. All of this now becomes irrelevant, and technically so does that. I'm just going to put a little comment like I did here. Okay. Cool. So what we need here is a way to write this kind of range contains thing that I want to do here. Just effectively see that our address is in that scope. So to do that, we're going to have to go back and take a look at our stabs information. So if we come back here, what we have is we have these labels for the open. So 192 is the open scope and 224 is the closed scope. And you can see that they are tied to labels. You see 192 says open with label LBB2, and LBB2, which is up here, corresponds to 009A. That's its address. The closing scope, let's see, 192, 192. So the closing scope of that one, the last one, is LBE2, which is 00B5, which would be, if I look here, yeah, right after the clear B. So this basically is like the end address non-inclusive, right? Because is that true? Let me think. We've got a return from subroutine. Right, that's interesting. So we don't actually consider, when we're on the return portion. That's weird, actually. So we do a clear B here. Oh, I guess, yeah, because that's called the epilogue, right? I suppose that when we're debugging, let me see here, the line 36, oh yeah, there you go, that's line 36. When we are on line 37 here, then we are at this label, B5, so it is inclusive. Yeah, it is inclusive. So you can see that when we're here, I guess it all depends on what we want to see. Like when we step and we end up on this closing scope, I guess we should, yeah, I guess it's not inclusive. We shouldn't see any of these variables anymore, right? That would make sense because we're on a return line. Yeah, so I'm going to consider it non-inclusive based on what I see in front of me here. Actually, it might be easier to just look at it here. We see that for the other label, the inner label, this LB, B3, and E3. E3 is over there. It says that the line before it is 11 and the next one is 32. 11, right, and then BE3, and then the next line is 32. So yeah, it is non-inclusive. We don't want to include this address because that would be the address of, let's say, line 32. So okay. Yeah, so it's what we expect. So it's inclusive for the beginning and non-inclusive for the end. So if we go back to our RST parser, where we are doing our stab stuff here, so here's our scope. Parent, children, variables, and we'll say maybe I'll use a std pair. Range. So we've got that, and add the first scope to the function. So we make a scope, we move our variables into it. We want to set the first to, let me see here. So it's the value portion. So that's at index 4. Actually, what I'm going to do, I'm going to do this. Now I have labels that I'm tracking. And I think I call them label to address. Yeah. I'm gonna have to do this in both places, so I guess I should just do this once on the outside. Oh, I don't know. I don't know if I'm doing one of these. Set scope range. Let's do this. Actually, yeah. Okay, let me just do it once and then we'll see what it looks like. So find our label. Label not found. Well, I guess I don't really, if I don't find a label, I'm not sure what to do here for the scope. If we don't find, if we can't, the range for the scope. Yeah, maybe we should return. If we return at this moment, this scope just gets destroyed. We never add it to any function, I suppose. So that's okay. Is that true? Yeah, because we haven't done this part of the code. Okay. So I say here function address is not quite right. What we want to say here is scope address, I suppose. Scope start address. And then similarly in the else branch, yeah, so here we don't want to do this. I mean, honestly, this would really be quite fatal. So I'm going to make this an error if this happens. And an error will just, you know, do bad things normally. Actually, it doesn't really. Just prints. We would need to, not this, I guess we would have to assert. Yeah, okay, yeah, it's fail that I want. Or my, see what do I have again? Fail message. Let's consider this fatal. Okay, so scope end address. And this becomes seconds. Okay. Is this good? Okay, that's good. Now I'm going to go back into my debug symbols here and just add a little helper. Bool. Contains. That's what I'd call it, right? I'm going to do scope.contains. And then here we'll pass it an address. Contains, good word. For now, I'll call it contains for lack of, because I can't come up with anything better. And it's going to be very simple. If, return that the address is greater than or equal to our range.first, and that range is less than, that address is less than range dot seconds. Contains encompasses. Maybe encompass is a better name. So if we come back to the debugger, I wanted to put the if here, right? So if scope.contains, scope dot arrow contains, no? I guess I can say if it doesn't contain it, just return. This needs to be const. That's why this is underlined. There we go. Skip scopes that do not contain the current address. All right. Let's see how this works. Well, let's get it to compile first. So what's the problem? Std pair. Oh yeah, I gotta give it two types. Of course. Still got the executable was locked. All right. Oh, looks like my failure has hit. Let's see what's going on here. So value is LBB2. Oh yeah, look at that. I don't actually have LBB2 in here. Was I not already parsing all the labels correctly? Maybe I'm not. So like this is an example. Should have parsed this. This might be the way my state machine is running. Let me see. Maybe I'm skipping those labels. So when I parse directives, That's not where I look for labels, is it? Okay, so while we're parsing directives, I'm looking for labels here. Now, I think what's happening is this is part of parsing instructions. Could it be that I am not doing this? Oh yeah, that's what it is. When I'm in this state, I'm not parsing labels. I'm only hesitating because I'm starting to wonder whether this way of having a state machine for stabs is even useful. I have a feeling like the way stabs is laid out, it's meant to be a line parser without a complex state machine. So, you know, maybe I don't necessarily need to do it this way, where right now what I do is I go into parse line instruction as soon as I see, what is this again? Stab dot, if it's a source line, so if it's 68, like here, I start parsing until I get to another stab line. I mean, I'm going to keep it like this for now, but I'm a bit on the fence on whether this is the right way. Having said that, I will add a function to parse label lines. It's an if. Okay. Okay. I guess I don't really need that. And if I did need it, it would go here. So the idea of that now would be to say if label line, if parse label line, and we can repeat ourselves. It's not the most elegant way of doing this, but it'll do. Because I guess why it's not elegant is that we might have other things to parse in instructions, in the middle of instructions. So we'll see. But for now, this should get us where we need to go. All right, let's hit this, F5. exception thrown. What's our problem here? This cursed scope pointer was null. Did I do this wrong? Oh, right, it might actually be null. We got to do this before. Right. Of course. Set the end address for the closing scope. Okay, so locals is empty. Hit F10. There we go, A and B. And C suddenly gets introduced. And now when we exit here, C is gone. Cool. And there we go, and we're on the last line. No more local variables from this scope. And let me see if I hit F5 again. Cool. All right, let's bring in the rest of our friends here. Compile this. This is very cool. All right, so let's go now with more scopes. We got A and B. Now we've got C. We've got another C this time. So you see it doesn't have the value 2, it's got some garbage value, that whatever was in memory. B hasn't even been set yet. Now C has 1, 2, A will have 3 again, I guess. Now we're in a scope where C and D exist. D hasn't been set yet. Now D gets a value. B finally gets set. And E replaces D, because D is gone out of scope, but E is in scope, so here we are. Gets set to 5, but then it's going to disappear. Yeah, that's the only thing that's a bit of a shame, is that we can't step to right after it gets set and like end on a scope here. That doesn't seem to be possible with the stabs architecture. There isn't like an instruction that lands us on the end brace, you know? Like here, 37 is there. LBN6. LBN6 is the same as LBN4. So I think it's these two here. And they both go straight to line 32. So there's no like, unlike when I'm debugging, say, in Visual Studio, where it introduces like an extra step line on the closing brace. There's no way really to see that here, so such is life. But yeah, it totally works. Now let's see with functions. If I call a function that has its own variables, because what I want to see now is, am I getting the scopes to work correctly? So actually, let's do this. Let's have main. Let's rename this to foo. So I'll start nice and simple. We just got a function foo that we call from main. Which means that, well, yeah, anyways, baby steps. Actually, ambiguates old declaration. All right, I can't call it foo because that's inside dummy. Let's call this bar. And let me remove my wait for debugger here. Okay, so F5. So here we are. Huh, that was interesting. It said canceled on B there. So what just happened there actually? Did it just crap out on me? Yeah. See, I wait, then it says locals B canceled, and then it stops debugging. So something is going wrong there. Okay. Probably it's my indexing for getting variables that's in a known function, but not at the right index. So let's put back our attach code here. There we go. Exception thrown, read access violation. Function pointer was something invalid. So let's see here. Function is empty. Okay. So this is, we are at the top. Yeah. But I don't have a known address yet. Yeah, so I guess my code before that was checking if I have a function made a lot more sense. I guess I can go like this. If function and then we add a scope. Okay. Oh, okay. I actually didn't make this guy safe. If iter is not equal to the ends, do that. There we go. Oops, didn't want to do that. Okay, so no crash as of now. All right, so that looks like it's working. So here's the trick. If I click on main, there are no locals. If I click back on bar, the locals show up as expected. You just go a little bit deeper here. So I've got 4, nothing, Very nice. So now the next thing we do is we're going to add some local variables into main and see that when we go between the two stack entries here between main and bar, that we see the right variables based on scope. Okay, so we saw this case. Whoops. So let's do a case where we introduce a scope here. And let's add a couple of other names here. Int x, int y. Let's call bar from there, and then let's add, int z goes to 2, bar. Then we come back here. Actually, I didn't test that, right? Like, if I have a variable that's, yeah, this is gonna show up int w equals to 4, bar. I think that should be good enough. And then, for good measure, another one here. Compile this. Oh. Keep doing that. Okay, this looks good. Let's shift F11 out of here. All right, so now we're in the scope with X, Y, and future W. Now, I know it's weird to see values like this. These are the values that haven't been set yet. It might be possible for me to make this a little bit smarter and like figure out when's the first time a variable is used, because that would be really nice. Like store with a variable the address at which it's first referenced within the scope. So that would allow us to like only show, in this case, probably just X, or maybe after we've set X it'll show up. I'm not sure. So that's something we could look at later. So here I called bar. So this bar call, we hit a breakpoint. We can see again all the variables that are in scope right now. And if we come back up, X, Y, and W with the values that they have. So does that make sense actually? No, it doesn't. This is incorrect. Right. I didn't do, so good thing I was looking at this. Yeah, these are incorrect because I'm using the wrong stack pointer. That's right. So when I'm doing the math here for getting the variable values, I'm supposed to use the stack pointer for the current frame. So see, this is incorrect. All right, let's go back. Should be easy enough to fix. Here. Up here we'll say constant 16 UT and we'll say stack address. So if we're at the top, then it's really just the current stack address. Otherwise, what? We go look again at call stack. Value that was stored in the CPU stack pointer just before the function was called. Yeah. So I think that means +1. Like it's similar to this one here, except we take stack pointer. Yeah. Too bad this doesn't line up a bit better. Such is life. Such is life with a code formatter. All right, so if that's the case, then we replace the read this part here with stack address. Yeah. Compile this. All right, here we are. Now let's see if this works. We go into bar, we hit this breakpoint. Okay. X is 0, Y is 1. So these are right now at the top of the stack. Now we're going to go into here. And now we're going to click up here. X is 0, Y is 1. So now that looks right. Three, 3, 2. Huh. So that's interesting that it says E is 5 because of the last time we ran bar. So the time we ran bar here, we went in there and it wrote those values at the same offset on the stack, which is why it's showing up correctly this time, which is okay. But it's more of a reason why we shouldn't be showing values yet, perhaps. It is confusing to see something that's not yet been set. 0 and 1, so let's get out of that function. So now we have a Z, 0, 1, W is 243. Now we're gonna, once again, we're gonna go in here. Does this make sense? It does. Yeah, same as before. And if I click here, yeah, we've got a Z with 2 here. Unfortunate that W showed up before Z. I suppose that's, why does that oh, because, no, that makes sense. It's because it's part of the same scope, yeah. Yeah, no, that makes perfect sense. 2, okay. Now W gets, so we got 0, 1, and 4. We go inside. That looks good. 3, 3, 2, 4, 0, 1, and 4. Sweet. Okay, this looks like it's working. Huh. That's pretty cool. Yeah, because you see, the only information that I have about variables is what scope they're part of, right? Which is what I'm using right now. But what I don't know is, and I know what stack offset they have, but I don't know like which lines of these refer to those variables. It's you know, there's comments in here that help you to understand, but there's no obvious way. You know what I mean? So yeah, like trying to infer the information about when a variable comes, like is first used. I guess the way to do that might be to do it like rather than know ahead of time which line, like from parsing this thing. Another way might be to say, I have these variables. They, I've entered a scope. I have a set of variables, and I could track whether or not those variables are, like the memory location it has ever been written to. I suppose I could do it that way. Maybe that's the way to do it. So for a given stack frame, to have a set of variables that for which we know their address and for which we're tracking whether or not a write has happened. So obviously that's a lot more work and somewhat optional for now. So it's a little orthogonal to this, but I think I will just write it down as a little to-do for myself, something to think about as a feature. So I'll say variables would be nice to only show the variables once they are written to. Or I can say it would be nice to show variables in the current scope on or after the line on which they are referenced. And I guess that pretty much means written to. Yeah, because otherwise you're reading from a variable that hasn't been initialized. The stabs info does not give us this. It does not give us the this information. The only way, okay, well, so one way options. Try to figure it out from the RST file. Either by, I mean, one way, of course, yeah, is to like do some kind of disassembling of the instructions to understand what they mean and to like figure out from the instruction, oh, is this one that will read from the stack? That's much harder. By looking at the comments. For example, or by disassembling the instructions and figuring out which ones are accessing the stack and at which offset. Correlate them to the local variables. Which stack offset. Alternatively, we could dynamically track, or say at runtime, when a scope, for variables in scope, track writes to the variable address and mark the variable as whatever, like track writes to the variable address to mark them as visible in the debugger. Okay, cool. Just wanted to get that idea down since it's since I think it would be nice. So now the only thing that I don't like about my solution is that there is no way, like right now I have variables and that's fine, that's all I have, right? But the way I'm storing this ID here means I don't know, what am I trying to say? No, sorry, it's here. Like let's say I want to create 3 scopes, right? One for variables, locals, one for registers. Let's say it's just those 2. Right now, I don't have a way to differentiate those because I'm just storing the call stack index here. So I guess what I would have to do is some kind of like, you know, I know that it's a 32-bit value. I could, you know, set a bit and use a mask to say this is a, all right? Yeah, I could do it that way. Well, I guess there's multiple ways I could do it, but that would be one way that would keep it simple. Just set a bit that says variable bit, right? This is a variable, and then another, and then I could have one for registers, and then I could just check and extract the value we need. Yeah, that would be easy enough. One thing I wanted to do is I noticed I didn't really like the behavior of it showing locals when there are no locals. So I think that's part of this, if there's a function or not. Actually not really, right? I'd have to do some code here. I'd have to add some code here to say, does this function, if there is a function, and does that function have any scopes, and do those scopes have any variables? One thing that I thought was interesting and strange was how it would show here. Let me just show what I mean. I don't know why exactly it does this. Let's build this. Thirsty. So you see here when we're at main, it's showing locals with this as if it has values under it, but it doesn't, you know? Yet, like when I click here, it does no such thing, but here it does. And maybe that's because it knows here there's no source, but why does it still say locals here? Like if I put a breakpoint here and I click up there, see now it's not actually hitting in my breakpoint. What about over here? Probably because it already made those calls. So if I hit F10, so now I'm going to get a call for my scopes request for the current frame, which is value 1, because we're on main. Yeah, that makes sense. Top of the stack. We're going to say we got this, and we're going to push it. And when we come here, we're going to traverse. We don't contain that. So we don't contain anything. So we don't add anything into the response. So the response comes back with no variables. And when that happens, somehow locals still has this little pull down thing. Now if I click here, we come back in here. We have a call stack index is 0. We've got a frame. Function is empty. In fact, I'm getting function for no reason, so I should remove this. Yeah, this is all from the code from before. This can all go. But okay, but I still don't understand. So we end up adding this same thing here with a different call stack index. We push it back. We're gonna not get a call for variables. Okay, so that's what's happening. Okay, so for sure if I check if there is a function, that's going to mean we won't see locals when we click there. But when we click here, it'll say there could be locals here, but there aren't any yet. I guess I'm okay with that. Okay, here's what we'll do. This small change will just make it so that when we have a function in our stack that does not map to a known function with debug info, we won't see variables. There are other ones we'll show it. If we really don't want that, I'd have to actually go through and, you know, maybe it's some information. I could do it so that like the function knows, but I guess it's fine. Who cares? It doesn't really matter. It's already pretty cool that it works. So now you see if I click here, it won't say variables because this is like an unknown source, unknown anything. Click there, we're going to potentially have variables. And as soon as we do, boom, we got variables like that. Very nice. What's cool is the hover works as well. Okay, so I can't hover on Z because it's not known yet, but I can hover on W even though it hasn't been set yet. That's pretty cool. I'm pretty sure it's going to crash if I try to add. I think there's possibly a bug in CPP DAP for this. Like if I put A here, yeah, I get this here. I don't know if it's because I haven't implemented something, but this looks like it's not really my fault. But normally watch should work. Like I don't think I have anything special to do for watches to work. I should actually try to see if the example works, the DAP example. Curious. Where is it again? Here, CPP DAP. Well, it's not crashing anyway, but it's not doing anything. I can't even step anymore. A not available. Try again, F5. Yeah, something's going on with this watch. See, now I can't even step anymore. But if I stop everything, remove this variable, and then go, no? Did I like break everything? Yeah, there's something funky going on there with watches. I'll look into that another time, I suppose. Okay, so this is pretty cool. Let me take a look at my changes here. Not CPP DAP, but rather, where did I? Made a lot of changes here. Right. Do some cleanup. So what did we do? We did some work on scope. We went with shared pointers everywhere. Added this to our scope here. Add function, get function by address. Okay, so DAP debugger, we are now storing the call stack index in here. Implementation of the variables request. RST parser doing a lot more work. Excuse me. Oh, man. Okay, so here's where we're parsing our open and closing brace. Oh yeah, that changed there. So let me just put these in here. That's it. All right, so what did we do? Last time it was RST parser. Implement or add supports, or how do I say this? Yeah. For displaying local variables. We now parse. Just want to put a couple of notes in here. So we now parse from from the stabs info. We now extract the variables and scopes information for functions. With this, we are able to implement, we implement the scopes and variables to display local variables in scope for the current stack frame. All right. So let's give that a little push. So in terms of what's next, there's a lot next. This is great. However, I presently am only supporting one data type, and that is int. So clearly that's not gonna cut it. We have a whole bunch of data types to support, but we start with int. We got scopes, we got functions, we got stacks, so we're in a really good place to start doing more. So let me write that down for the next time. So much notes. This is done. Support multiple. Okay, actually, I already have this. What it is that I have all these notes here about local variables and about data types. I already thought about that. Yeah, it's all here. this whole section here is what we need to be doing. Types. So I'm going to focus obviously on primitive types first, and then eventually on user-defined types. So like classes, structs, all that kind of stuff, you know. But yeah, just getting the basics is going to be great. Like we can see the whole slew of the basic data types we got to support right here. Some of these we don't need to support. I'm not going to support complex. Don't know what to do with built-in VA list yet. We'll see. But I don't think I have to care. But all these other ones, like long unsigned, all these things here, all these data types, eventually even the vtable pointer. But we're going to start with this set right here. And that's going to cover quite a bit. And then once we have that, then we can start moving on to pointers and references, which are the same. Obviously, that's going to be very important. And then we'll do like structs classes, so like compound data types, and all the code that goes along with displaying that. So once we have code for displaying these basic types, then compound types will be, you know, and pointers and references, and then compound types will be built on top of those primitives. So it's a lot of work, but that's what it takes for a debugger to be useful, right? Is to actually show you values. Oh, hey, Bama. Sorry, I don't know if I don't know when you wrote there. I just saw your chat message. Sorry for not seeing it if it's been a while. Because I was sort of like wrapping it up over here. So did you just join, Bama? Because I can give you a little demo if you're before I sign off. Maybe you're not here anymore. So yeah, so that's what I'm going to do. I'm going to focus on implementing these basic data types and then doing the compound types. And that'll be really, really interesting, because then we'll be able to ultimately my goal is to take, right now we're working with this very simple example so that I can iterate on it to nice and all that. But then I want to go back to my Vectrex Pong, which is a lot more complicated. It's got templates, pointers, like lots of scopes and functions everywhere. So it's a much more realistic load, if you will. And it'll be cool to see like looking at the results of those values instead. Yeah, so I think I'm gonna stop here, and I'll be back at this in a couple of nights on Thursday. So thanks for watching, and I'll catch you next time.